My name is Sanaea Rose. I'm a postdoctoral fellow at Sierra at Northwestern University, and I study how interactions at the center of our galaxy lead to unique populations of stars, binaries, and black holes.
And what were the difficulties you encounter in your career, and what kind of advice do you have for people going through the same difficulties?
So I think the hardest part about being an astrophysicist is there is so much that you don't know. There's a lot of things that we don't know yet about the universe, but there are also a lot of things as you're working in a specific field that you don't know yet that people have already studied. And it can feel very overwhelming to figure out where to start and where to move next and where to branch out. And I think part of being a scientist is being uncomfortable with not knowing things so that you're driven to figure out more stuff, and also comfortable with not knowing things so that you want to stay in the field. And I think the advice I would give to people facing a similar sentiment or feeling would be to talk to other scientists and to talk to their peers and scientists who are senior to them, because I think that they will find, and what I've found is that most people feel like they don't know what they're doing. And we're in a highly collaborative field, and the point is to speak to other people and to together forge a path forward.
What do you think would be necessary to bring more people studying physics or astrophysics?
I think, so this is something that drew me to astrophysics, and I think it's a potential area that we could look to as a way of bringing more people in, and that is the interface between science and art, astrophysics and art. And I found this a lot on the side of dance because that was my path. I began in a ballet program. There were a lot of choreographers and ballet directors who were very interested in physics and astronomy and science, and that inspired a lot of their work. And I imagine that there are similar things with music and painting, and I think we can work with that and explore that intersection more.
And what is your topic of research, and how would you explain it to elementary school children?
So I study interactions between stars. So our sun is a star. It's the star that we're most familiar with. And we're fortunate to live very close to it, and so we know how it looks, we know how hot it is, we know how big it is. But stars are actually a very diverse set of objects. So you could have much bigger stars and much hotter stars. You can also have much smaller stars. And the thing is that our sun is a very lonely star. So there are some planets around it, which is nice. We live on one of those planets, but there aren't really any other stars that are close by. However, there is one environment in our universe at the very, very center of the galaxy where, not one environment, but near us, at the center of our galaxy, there are actually many of these in many different galaxies, where there are lots and lots of stars like our sun, and also lots of stars that are a little bit different from our sun, all packed in like sardines into a very small volume. And this means that these stars, they can brush each other, they can smash into each other, they can come together and form a bigger star, kind of like if you just take clay and put it together. And so I study what all of these things mean for what we see in this area of our galaxy from Earth.
And what about bachelor students in physics? How would you explain to them?
So there is a supermassive black hole at the center of our galaxy, and it is surrounded by a dense cluster of stars and the dead remains of stars like black holes, smaller black holes and neutron stars and white dwarfs. And this region is so dense, it's actually 1 million times denser than our solar neighborhood, that physical collisions, direct collisions between these objects become possible. And these objects can also interact gravitationally, so they're frequently passing by other neighbors, and this can cause their trajectory to change very, very slightly. So altogether, these interactions mean that you can have objects collide and merge. Stars collide and merge and form bigger stars that look kind of peculiar. You can have stars collide at such speeds that they don't merge and they instead throw off their outer layers and become peculiar stripped stars. And you can also change overall what the population would look like. So what masses of stars you see, how they evolve, and the sizes of the compact objects that you'd find in this area.
If you enjoyed the video, like and subscribe.